Check it.
Okay, welcome back. Today we're going to be talking about dividing polynomials. Now we've already done addition, subtraction, multiplication of polynomials. Now we're dividing. Now there are two types of division we're going to talk about in this lesson. Simple division and long division. And then tomorrow's lesson, in day 2, we're going to talk about synthetic division. All right, so let's get started here. Now the first one, simple division, we actually have already done this. It's just called splitting the fraction. I've referred to it as the Hart method. But let's just review here really quickly. So let's say you have something like this. It says simplify this polynomial, this binomial, two things here, divided by this monomial. Now this may not look like division to you, like it looks like multiplication because they're next to each other instead of on top of each other. But notice this little thing they have here. There's a -1 power here. A -1 power means flip. So this is just a division problem in disguise. Not a problem, we can deal with it. So what does this look like? Well, you can rewrite it like this. So there you have the top, and now this gets flipped to the bottom. So really this is 1 over that, right? When you flip it. And that means it ends up on the bottom here like this. And there you go. Now that's a division problem. It's something on top divided by something on the bottom. Now, if you were doing long division, you would put this thing outside here and do your long division. Hopefully you recognize this from middle school or even elementary school, long division. Except you did it with numbers. You did like 5 divided into 2947 or something, right? And it's the same idea, but we'll get to that later. Now, for the purposes of splitting the fraction, you have to only have one term in the denominator here, meaning no pluses and no minuses down here. If this was like 3x plus y, that would be 2 terms and you would not be splitting the fraction. But since there are no pluses or minuses in here, this is one term. This is one term plus another term over one term. You have a single term in the denominator, you can split the fraction with what we sometimes call the Hart method, right? Which I call the Hart method. And you end up with this. You end up with 18 like that, and you end up with this. Okay, and now that we have split the fraction, we can reduce each fraction individually. So we have 18 over 3, we have x squared over x and y over y. 18 over 3 is 6. X squared over x, it's x to the second divided by x to the first. You subtract the powers, you get x to the first, which I'm not going to write the 1 there. And y over y, this is y to the first over y to the first. You subtract the powers, you get a 0, and y to the 0 is the same as saying 1. So y over y is 1, or anything over itself is 1. So really times 1, I don't need to write that. Plus 27 over 3, that's a 9. X to the third divided by x to the first. You subtract the powers, 3 minus 1 is 2. Y to the second divided by y to the first, you subtract powers, you get a 1, y to the first, which I'm not going to write. And here you have z to the 1 and no z at all. That's the same thing as having z to the 0, right? So 1 minus 0 is still 1. Or if you just look at it, you're not really dividing. It's z to the first and there's nothing, you're not dividing by anything, so you just bring it down. And that's it, you're done. That was splitting the fraction and simplifying. So that we've done before. I just wanted to run through it as the simplest kind of division. We've touched upon that already. But if you have more than one term in the denominator, if there's a plus or minus in your denominator, you do not want to do this because it leads to a much more difficult situation and an answer that you can't really use. So let's take a look at another problem here. Down here, we have a division problem, and you notice that the denominator has 2 terms in it. There's a plus in between the 2x and the 3. So this is not one term, this is 2 different terms. This is 2x plus another term, 3. So when you have multiple terms in the denominator, splitting the fraction does not work very well. Okay, I'm not saying it's impossible, it just works really poorly and gives you an answer that is unrecognizable. So, can you split the fraction? We're not going to. You can, but we're not going to. All right, so we're going to use some other method here. Now, since we can't split the fraction, we're going to have to use long division. Now, just to kind of remind you how long division works, back in middle school, you might have done something like this. 5 divided into, 29, 46, I'll throw on an 8 there, right? And if you remember how this works, this is the number you're dividing by this number here. This is, okay? So you're taking your dividend, you're dividing by your divisor. What's 29,468 divided by 5? Well, you put the 5 out here, and you would go, how many times does 5 go into 2? It doesn't. How many times does 5 go into 29? 5 times. Then you would multiply this 5 times this 5 and write the result down here. 5 times 5 is 25. And what did you do? You subtracted. 29 minus 25 is 4. And then you brought down the next term, and then you started the process over again. 5 goes into 44 8 times. 8 times, that's 40, right? And so on and so forth. And if you had, look, actually, let me make some room here. If you had a number left over, that was your remainder, right? So, okay, 40 minus 4 is that. Then you bring down the 6. 40 into 4, 5 into 46 is 9. Times 5 is 45. Bring down the 8. 5 into 18 is 3. And you had a remainder of 3. That's when you first learned division. You wrote a little r with the 3. But then later on, they showed you what you're supposed to do with your remainder. Okay, so I'm sorry, I didn't finish this, so 3. What you're supposed to do with your remainder was make a fraction out of it. This is 3 over the divisor. So this became 3/5. So that's a little quick review of long division from middle school or even elementary school. I don't remember when you guys took it. But anyway, the point is, it's something that you already know. We're going to be doing the exact same process, but we're going to be doing it with letters. That's the only difference here. Okay, so let's come down here. We're going to be doing long division here. The divisor is the 2x plus 3, the thing you're dividing by. We'll put that outside. And then inside will be the thing on the top here. 8x squared plus 8x minus 6. Now, look at the first term. If there's multiple terms here, so look at the first term only, and look at the first term here, and ask yourself, how many times does 2x go into 8x cubed, 8x squared? Well, another way to look at this is to say, what would you multiply by 4x to get 8x squared, right? So this goes in 4 times, right, would be one way to look at it. But then what about the x's? It's kind of hard to say just how many times it's go into. So what you can say is, what would I multiply by 2x to get 8x squared? The answer is 4x. Think about that. Is 4x times 2x 8x squared? Yes, it is. So now we do that same thing we did up here, and we'll multiply whatever number we came up with times this and put it down here. So we'll do the same thing here. 4x times 2x, 4 times 2 is 8, and x times x is x squared. And you can see that works. But now you still have to multiply the 4x. We did that already. We still have to multiply the 4x times the 3 here. So what's 4x times 3? It's 12x, right? And where do you put it? Underneath the next term here. So plus 12x. Like that. Now, if you remember, the next thing we did was subtract, right? So after you multiply this times this and put it here, you subtracted whatever was above minus 29 minus 25. Well, here we're going to do the same thing. We're going to subtract this minus this. How do you subtract? You just basically flip the signs on the bottom one. So this is a positive 8x squared, make it negative. This is a positive 12x, make it negative. So what's 8x squared minus 8x squared? Nothing. 0, right? I could write a 0, but I'm not going to bother writing a 0. What's 8x minus 12x? It's negative 4x. And now, just like in long division from middle school, you're going to bring down this number, this negative 6 here. So bring down the negative 6. Now, you look at this and say, all right, first term into the first term, what would you multiply by 2x to get negative 4x? Looks like negative 2. So just put down a negative 2 up here. Now take that negative 2 and multiply it by both of these, kind of distribute it, and then put the results down here. So negative 2 times 2x is negative 4x. By the way, this first one has to match because you chose it that way. So if this doesn't match, you're doing something wrong. And then negative 2 times 3 is negative 6. Now subtract. Well, when you subtract, you're just changing the sign on the bottom. So this becomes a plus 4x, this becomes a plus 6x. This becomes 0, and this becomes 0, and you have no remainder. So you're done. The answer is 4x minus 2. So what does this tell us? Well, if you have the original problem here, you know that dividing this by this gives you this. Well, this means that this has to be a factor of the dividend. This has to be the factor of this. And this also has to be a factor of this, because this times this has to equal this, if you think about how this works. So now we can actually use the results to factor stuff. Okay, that's the whole purpose of learning division of polynomials. This is a way of factoring. Okay, if you know one of the factors of a polynomial, you divide by that factor and you get the other factor, or factors. So that means this 8x squared plus 8x minus 6 is actually 2x plus 3, which is what we were given, times 4x minus 2. you have just factored this polynomial here. Now, I don't want to box that because it's not like an answer to a question, but you see what I'm talking about. You do get a factorization here. So the idea is, let's say you're trying to factor this polynomial and I tell you 2x plus 3 is one of the factors. You can use division to find the missing factor, the other one, or ones. There might be multiple factors here. There you go. So use the results to factor. There it is. Actually, that is the question, so I can box it. And there we go. All right. So let's go on to the next question here. We have x cubed minus 3x squared minus 4x, and we're dividing by this. And the question is, well, the question is divide this, but also use the results to factor the dividend. Okay, so let's see. Oh, by the way, if you get a 0 remainder, then this is possible that you have factors. But if your remainder is anything other than 0, then that means this thing is not factorable. Like you can't factor using the factor that you were given. So yeah, in order for this idea of factoring to work, you have to have no remainder. Sometimes you will have a remainder, which means it's not factorable, or it means you made a mistake. But if you didn't make any mistakes, it means it's not factorable using the factor given. Okay, let's come back here. Let's set this up as long division. And here we go. Look at the first term here and look at the first term here. What would you multiply by x squared to get x to the third power? Another x. Okay, and now take that x and distribute it back here. X times x squared is x to the third, and x times x is x squared, positive. Now subtract. Well, subtract means flip the sign. This becomes a negative, and this becomes a negative, and add once you flip the signs. Well, this minus this is going to cancel out. And these are both negative now, so this is going to be negative 4x squared. Now bring down the next term. Now look at the first term here again. What would you multiply by x squared to get negative 4x squared? Well, it looks like negative 4. Now when you distribute that negative 4 back down, you should get confirmation. You should see that this matches. So negative 4 times x squared is negative 4x squared, so that works. So you know you're doing this right. And negative 4 times x is negative 4x. Now you're going to subtract, which means flip the sign and add. Well, that makes both of these go away. You have a remainder of 0. So what does that tell us? It tells us that here's one factor and here's the other factor, because this is a 0. Since this is a 0, these must be factors. And let's put it this way. If you have 24 and you divide it by 8 and you get 3, that means 24 equals 8 times 3 because there's no remainder. But if you have 25 and divide it by 8, you're going to get 3 with a remainder of 1, right? And that means 8 is not a factor of 25 because it doesn't go in evenly, right? Going in evenly means 0 remainder. So I'm just pointing out that you need a 0 remainder to say that something is a factor of something. Anyway, now we can factor this thing up here. This right here is the same as this factor, which was given to us, times this factor, which we found by division. Now here's the thing. This is not fully factored. Why? Well, this is fully factored, but there's a GCF in here. Yeah, you can still factor this itself. So this right here looks like there's a GCF of x. So we can pull out the x, and now what's left in here would be x plus 1. You can check that, and that works. So actually now it's fully factored, and that's what we care about, being fully factored. And that wasn't too hard once we did the division here. Okay, there you go. So don't leave it like this because you're going to lose points if you leave it like this. Look at this thing. It's still factorable. Okay, next one. Now this next one has a little trick in it that you have to pay attention to. If you look at the powers here, this is a power of 4 and a power of 2. Where's the power of 3? It's not there. And then it goes from a power of 2 down to no power at all, which is a power of 0. Where's the power of 1? So there are some missing powers here. So we need to fill in the powers before we can long divide. Here's what I mean. Let's set this up as long division. Here's the divisor. You cannot just write x to the 4th minus 3x squared minus 18. This isn't going to work. So what you need to do is fill in all the missing powers. So the highest power is 4. That's fine. That you have to come down 1 power at a time. So where's the power of 3? There is none. So what you do is put in plus 0 x to the 3rd as a placeholder. Then we do have a second power, negative 3x squared. Where's the first power? There isn't. So you put in plus 0x to the first power. And then there's minus 18, which is the 0th power. So that's the idea here. If you're long dividing, okay, and you see that there are powers missing, you have to put them in. Now, there were no powers missing in the first two examples, so I didn't do this. But now, there are some powers missing here. I need to fill them in. And once you do that, the rest of this should go smoothly. So let's go ahead, and it says use the results to factor. So presumably our remainder should be 0. Okay, and we'll get the factorization. Okay, so here we go. X into x to the 4th. What would you multiply by x to get x to the 4th? You'd multiply by x to the 3rd. Now distribute that x to the 3rd times both of these. X to the 3rd times x is x to the 4th. And x to the 3rd times -2 is -2x to the 3rd. Now you can see that if I didn't put in this 0x to the 3rd, I wouldn't have any place to put this underneath. The powers have to match. You see, that's why you do this. Anyway, now we subtract. So this becomes a minus. This is already a minus, so it becomes a plus. Okay, that cancels out as it's supposed to. And this becomes 0 plus 2, which is 2x to the 3rd positive. Now bring down your next term. This is a -3x squared, and continue the process. What would you multiply by by x to get 2x to the 3rd power? You'd multiply by 2x squared, right? Check it. 2x squared, I meant to write squared. 2x squared times another x is 2x to the 3rd power. So that does work. Okay, you're going to multiply this times this and this times this. So you get 2x to the 3rd here, which is supposed to match. And then 2x squared times -2 is -4x squared. Now subtract. Make this negative, make this positive. These cancel out, and this becomes 4x squared minus 3x squared, which is 1x squared, or just x squared. Bring down the next term, plus 0x. Now, what would you multiply by x to get x squared? Another x, right? So when you do that, x times x is x squared, and x times -2 is -2x. And now we're going to subtract, which means changing the signs. So this becomes a minus and this becomes a plus. These cancel out. This becomes 0 plus 2x. So this is 2x. Bring down the last term here, minus 18. What would you multiply by x to get 2x? Multiply by 2. 2 times x is 2x. And 2 times -2 is -4. Now subtract. This becomes a minus. This becomes a plus. Positive 4 plus -18, or 4 minus 18, is -14. There's a remainder here. We're done, and there's a remainder because x does not go into -14 at all. There's nothing you can multiply times x besides dividing or something. There's nothing you can multiply by x to get -14. So you're done. This is a remainder, which means this is not a factor. There might be other ways to factor this thing, but not with x minus 2. Did I write fraction? Factor. Okay, so we do have an answer for the division. The answer is x cubed, right, plus 2x squared plus x plus 2. And now our remainder is -14. So here's what you do with the remainder. Okay, if you remember with the long division example, we took the remainder and put it over the divisor to make a fraction, 3 over 5, and there it is, right? Well, here we're going to do the same thing. We're going to take that -14 and put it over the divisor x minus 2. So this becomes -14 over x minus 2, okay? But one thing we do have to do is put a separator because we're not multiplying these things here, so we have to put a plus here. Now technically plus negative is a minus, so you could also write it this way. So the plus negative becomes a minus. Technically this is the way you're supposed to write it. So I'm going to box that, okay? Never write a double sign. So if you have 3 plus -2, you're supposed to change that into a minus, and it's 3 minus 2. You're not supposed to keep a double sign like that. So, but I just want to show you that whenever you have that extra fraction that comes from the remainder, you're supposed to put a plus here and then put the thing here. Now, after I did that, I realized, okay, I have to simplify these signs, and I get a minus. But don't just leave an empty space there for one thing. And don't put it right up against here, because that'll become multiplication, all right? So make sure you have the appropriate sign. Now, if you think about it, if you go back to here, this is 5893 and 3/5. Well, you could put plus 3/5 here. That wouldn't change anything, right? You're not multiplying this times this. That's why we don't use mixed numbers anymore, because they're kind of contradictory to what we do in algebra. Okay, so there you go. Don't forget to put in your placeholders. One last question here real quick, and we'll call this a day. So this time they're doing that thing where they put the -1 here. So this is the divisor. This is going to end up on the bottom. And you also notice that there are powers missing here. So this is kind of your ultimate question for today. All right, ultimate meaning last. Okay, so this is going to be our divisor. right? This is the same as having it on the bottom of a fraction, having the -1 there. So 3z minus 6 is going to be your divisor, the thing outside, or if it was a fraction, the thing on the bottom. And we better make this pretty long because we have 6 powers here to write. So 6z to the 6th. There's no 5th power, so we need to put in a placeholder for the 5th power, 0z to the 5th. There is a 4th power, so we'll copy that down. There's no 3rd power, so put in a 0z to the 3rd power. There is a 2nd power. There's no 1st power, so put in a plus 0z to the 1st power. And technically, you can even do this, but we may not need it. That would be 0 to the 0 power, z to the 0 power. Okay, we might not need to go this far, but definitely make sure you have all the powers of z here. So 6, 5, 4, 3, 2, and this, even though we don't write it, is z to the 1. You have all of your powers here. This is z to the 0 technically. We may or may not need that. We'll see. Okay, most likely we don't. All right, so actually let's just erase that, and if we need it, we'll add it in later. Okay, so here we go. What would you multiply by 3z to get 6z to the 6th? 3z to the 5th. Okay, when you do this, it's almost like a check now. When you multiply this times this, you have to get this. Oop, not 3z, that's a 2. Sorry, my bad. So that's a 2. And when you multiply these, 2 times 3 is 6. Z to the 5th times z to the 1st is z to the 6th, right? Now it matches, you know this is right. Now, 2z to the 5th times -6, that's going to be -12 z to the 5th. Because there's no z at all here, you're just bringing down that. Okay, now subtract, which means change this to a negative and change this to a positive, and add 0 plus 12 is 12, z to the 5th, and bring down your next term, plus 3z to the 4th. And now we can start the process over again. What would you multiply by 3z to get 12z to the 5th? Well, 3 times 4 will give you 12, and z to the 4th times z to the 1st. So 4z to the 4th. Oops, not x. 4z to the 4th. So this, look, let me erase these here. This times this, 4z to the 4th times 3z to the 1st. 4 times 3 is 12, and z to the 4th times z to the 1st is z to the 5th. That works, so this should be the right term here. Now, 4z to the 4th times -6, -24z to the 4th. Now we want to subtract, so change the signs on the bottom ones. That becomes a minus, that becomes a plus. Those cancel out as they're supposed to. And we have now 27, because it's 3z plus 24z to the 4th. 27z to the 4th. And bring down your next term. This is plus 0z to the 3rd. All right, what would you multiply by 3z to get 27z to the 4th? 9z to the 3rd. 9z to the 3rd times 3z is 27z to the 4th. That works. 9z to the 3rd times 6 is -54z to the 3rd. Change the signs, add. We get 54z to the 3rd. Bring down the next term, minus 9z squared. Yes, this does take up a lot of space. Let me zoom out a little bit here. What would you multiply by 3z to get 54z? All right, it's going to be 18. And then what would you multiply by the z to get z cubed? Z squared. So 18z squared. Okay, and now here we go. 18z squared times 3z is 54z cubed. Z to the 3rd power. 18z squared times -6. Well, 18 times 6 is 108. So this becomes -108z squared. I'm going to subtract now. So this becomes a minus, this becomes a plus. 108 minus 9 is 99. So we get here positive 99z squared. Bring down the 0z. Looks like we're going to have a remainder here. Finally, no, actually probably not. Okay, so keep going. What would you multiply by 3z to get 99z to the 2nd? 33z, right? So plus 33z. 33z times 3z is 99z squared. 33z times 6 is 198, negative 198z. We're going to change the signs. These cancel out. We get positive 198z. Now, remember I said that we might need a plus 0 here? We actually do, because now we have to bring down the next term. And there's definitely going to be a remainder here. So 3 into 198, what do you need to multiply by 3 to get 198? 66 actually. 66 times this will give you this. And 66 times 6 is going to give you negative 396. Now, you subtract, you make this negative, you make this positive. I hope you're not watching on a phone. Anyway, things are getting pretty tiny here. And you get a remainder of 396. 396. Okay? So where do you put your answer? Where do you put the 396? Well, you can come over here and put plus, and then your fraction. The fraction is 396 over the divisor, which is 3z minus 6. And that, my friends, is your answer. Okay? All right, we are done. See you at the next video.
Check this.